started with suppose my function is differentiable, and we proved a relation. We got a relation that derivative is ux plus ivx once we go from real axis. Now later when we go from imaginary axis, then we got that f dash is vy minus ui I. Comparing 1 and 2, we got a relation that is ux equal to vy and ui equal to minus vx, and this equation is called Cauchy-Riemann equation. Then I just reframed the whatever we proved, I reframed as a statement, as a theorem. And that is, suppose that f of z is u plus iv and derivative exists here. Main condition is that only derivative exists at a point z naught, then first order partial derivative of u and v must exist at that point, and they must satisfy CR equation, because that is Cauchy-Riemann equation. And what is Cauchy-Riemann equation? Ux equal to vy and uy equal to minus vx. You just remember this because we will be using a lot of time. Also derivative can be written as derivative will be ux plus ivx. Okay, and later on we saw some examples where the first one was f of z equal to x square minus y square plus I 2xy. Okay, now remember one thing, as we know derivative exist imply CR equation satisfied, correct? But what will be the converse of this? If the function is not satisfying CR equation, then it is not differentiable. So we can use this to prove whether it is not differentiable. That is, I have written in the box. Uh, if the to prove function is not differentiable, you can use this property, previous theorem. That is, if it does not satisfy CR equation, then the conclusion will be it is not differentiable, because differentiability implies CR equation, correct? And converse is not true. That is, CR equation does not imply differentiability. So not CR equation imply not differentiable. And f of z, that means this is sufficient. CR equation is sufficient for me. If CR equation is not, then this is false. F of z is differentiable everywhere, and derivative, and we just solved that derivative. We saw that this satisfies CR equation, and yeah, u and we saw that CR equation is satisfying, and derivative is ux plus ivx, and that is 2z. Yeah, and later on we saw this f of z equal to mod z square. Can somebody tell me what is u of xy? What is mod z square? That is x square plus y square, correct? Plus 0 times I. So what will be my u? U will be x square plus y square, and what will be my v? V will be 0. Now can you quickly check whether it is satisfying CR equation? What is CR equation? First find ux, uy, vx, vy. What is ux? It is 2x, and it is 2y, correct? And this is 0, 0. Okay, does this satisfy CR equation? No. And when will this satisfy? What is CR equation? Ux equal to vy and uy equal to minus vx. When will this satisfy? You see, when these two people will be same, what will be the condition? And when these two people will be negation of one of each other? What is your observation? Yes, do you have any observation here? That means if you want to say ux equal to vy, that means if I want to make this ux is same as vy, I should have this guy as also 0, correct? That means what? CR equation is satisfied, correct? X is 0 and y is also 0. That is, CR equation is satisfied only at 0, 0. So what can you conclude here? Can I conclude something? F is not differentiable. I don't know whether it is differentiable at 0, 0. I don't know about that. But I am sure that it is not differentiable at at any point other than 0, 0. Do you agree with this? Think about it. As I already told you, differentiability implies that function must satisfy CR equation. Okay. Now in this case, I saw that CR equation is not satisfied by any point other than origin. CR equation is satisfied only with 0, 0, only at 0, 0. So I don't know about 0, 0, whether it is function is differentiable at 0, 0 or not. We don't know about that. But we are sure that CR equation is not satisfied by any other point other than 0. So I can conclude that it is not differentiable at any other point. Do you agree? Yeah, and if you remember, I have already proved that this function is not differentiable. Let me go back and show you if it is available. Just keep checking if you see mod z square somewhere. Yeah, do you see that? I started f of I was checking whether it is differentiable or not. Then we saw that f of z equal to mod z square, and we solve it, and then later on we saw maybe we have concluded something. Yeah. You see that derivative exists at z equal to 0 only. Derivative does not exist at any non-zero. We have already proved it, and now we have proved it with the CR equation that it does not satisfy CR equation at any other point other than origin, so it is not differentiable. But still, we are not sure that whether function is differentiable at 0. From there, we are sure, but from here, we are not sure that it is differentiable. Correct? Do you see? Yeah, is the conclusion okay? Do you understand that? From here, we can conclude only this part. We cannot conclude that whether function is differentiable at 0, 0, because as I told you, differentiability implies CR equation, correct? But once it is satisfying CR equation, I cannot say it is differentiable. Correct. So your next question should be, sir, can I include some more property with this CR equation and this, and can I go back to differentiability? That means if a function is satisfying CR equation also and something else in some other condition, then can I say whether it is differentiable? Do you agree? I just want to go back. That means I want a sufficient condition for differentiability. CR equation was a necessary part, necessary for me. अगर CR equation नहीं होता तो I will say not differentiable. But CR equation is necessary part. Now I want a sufficient condition to say if this is satisfying this, then I can say function is differentiable. Do you agree? Because only if you are having CR equation, only if your function is satisfying CR equation, it is not sufficient to say that function is differentiable. Correct? As we proved. So now let us write sufficient sufficient condition for differentiability. Okay, I'll state the theorem first. Let the function f of z is equal to u of x y plus I v of x y be defined throughout some epsilon neighborhood of a point z naught that is equal to x naught plus I y naught. And suppose suppose that it is satisfying two properties, that is first a uh, the first order partial derivative of the function u and v with respect to x and y exist in the neighborhood. The first condition it should exist. Second condition, those partial derivatives are continuous. They must be continuous at that point. Correct? And satisfy CR equation. Equations. That is, what is CR equation? Ux equal to Vy and Uy equal to minus Vx. Just remember this, okay? At x naught y naught. Then f dash of z naught exist and its value f dash of z naught is equal to ux plus ivx. Correct? And where right hand side is evaluated at x naught y naught. Ux plus ivx at x naught y naught, since I am taking z naught, so I should you should understand that. Okay, so did you understand the statement? What was my question in the previous part? My question was, if I am given differentiable, that is, let us see the statement. Here I got to know that if my function is differentiable, then I know it is satisfying CR equation and the derivative is this. Correct? Now my question was, what is the converse of this? Can I go back? That means if my function is satisfying CR equation, can I go back? Can I say the function is differentiable? Correct? So and the answer was no. We'll give a counter example where the function is satisfying CR equation, but it's still it is not differentiable. We'll see. We'll see. There are some examples, and I think हम लोग ने किया भी है. If you take some function which is not differentiable, we have done so many functions which are not differentiable, and we'll see that those functions are satisfying CR equation, but they are not differentiable. So CR equation is not a sufficient for me. CR equation is just a necessary condition for differentiability. It is not sufficient. So the next question should be, can we make some more condition on this, and can I get a sufficient condition? And that is what here the theorem comes. That is, your first order partial derivative. That means ux, uy, vx, vy, they must exist in that point. The first condition is they must exist, and second condition is these partial derivative are continuous. They must be continuous also. They should exist. They should be continuous, and then they should be satisfying CR equation. Then only you can say the function is differentiable. Do you see the extra condition? What is extra? Extra is you can consider only continuity, because तुमने तो पहले ही बोला था सी आर इक्वेशन सेटिस्फाई, तो सी आर इक्वेशन सेटिस्फाई तभी करेगा जब दे आर existing ux vy uy vx ये exist करेगा तभी सी आर. So this is not part of my core. That the main part is your partial derivative must be continuous also. Should be continuous and it should satisfy CR equation, so you can say it is differentiable. Okay, now to check differentiability we have a theorem. We will just check whether partial derivative exists and whether partial derivative is continuous at that point. And then, so can you say about this, what is ux, what is uy, what is vx, uy? We saw that the function is satisfying CR equation at 0 0. Correct? Can you say something whether ux, uy, vx, vy, whether it is continuous at 0 0? whether it is continuous at 0 0. Can you say something? Since it is just a polynomial, no? It is linear function, you can say. So at 0 0 it is continuous, correct? So once it is continuous, so we are satisfying both the condition. We are satisfying both the condition. So can I conclude that this function is differentiable at origin, and this is not differentiable anywhere else. Why it is not differentiable anywhere else? Because this is not satisfying the necessary condition only, that is CR equation ही नहीं हो रहा है, तो क्या बोलेंगे? Correct. Now the main part is, let us prove this. वो सब तो ठीक है साहब, solving will be easy. Now let us try to prove. uh, Try to see क्या क्या given है अपने को. First we are given with first order partial derivative of function u and v exist, and they are continuous, that is also given to us. We want to prove f dash exists. What is the value of f dash? Ux plus ivx. So this is what we want to prove. Okay, shall we start? Yeah. So for the differentiability, what we require this. Yeah, let me start. Suppose we are assuming the first and second hypothesis. Suppose we assume, बार बार लिखने से अच्छा I'll just write this. We assume that the conditions A and B in the hypothesis are satisfied, and write delta z as delta x plus I delta y. Correct? This is what I am writing. And where, let us take where 0 is less than mod z, mod delta z, and that is less than epsilon as well. Let us consider this. So, and one more thing, delta w we are taking as f of z naught plus delta z minus f of z naught. Correct? Do you see differentiability check करने के लिए क्या करना रहेगा अपने को? I need to find this, divide by delta z, and that should exist, that limit should exist. Correct? So delta w क्या आएगा? What is f of z naught plus delta z? It will be, you can write it as, डेल्टा डब्ल्यू को मैं ऐसा लिख रहा हूँ, देखो, डेल्टा यू प्लस आई डेल्टा वी, वेयर delta u, try to see whether I am correct or not, and delta v, where delta u will be u at x naught plus delta x, comma y naught plus delta y minus u of x naught y naught. Correct? And here it will be v of x naught plus delta x, comma y naught plus delta y minus v of x naught y naught. Just try to see whether I'm correct or not. What was your function f of z naught plus delta z? The coordinate will be x naught plus delta x, y naught plus delta y, and that's it. Real part को real part से subtract किया, so you'll be having this minus u of x naught y naught and this. Do you agree with this? Okay. Now, if you remember your semester 3 SYBSc, whenever your function is differentiable or whenever your partial derivative are continuous, so we can use something. Now, what is that something? Let me write, then you will remember. The assumption that the first order partial derivatives u and v are continuous at x naught y naught enables us to write delta u is equal to ux x naught y naught multiplied by delta x plus uy x naught y naught multiplied by delta y plus epsilon 1 delta x plus epsilon 2 delta y, and similarly for delta v also. Delta v is equal to vx at x naught y naught delta x plus vy x naught y naught delta y plus epsilon 3 delta x plus epsilon 4 delta y. Now first let us understand this part what we are writing. We are using the condition that ux and uy are continuous. So can I write my delta u? What is my delta u? You see delta u is this minus this. Their subtraction can I write like this? If you remember it properly, अगर इसको मैं डॉट प्रोडक्ट में लिखूँ तो ये कैसा रहेगा? It will be something like ux and uy dot product with delta x and delta y. Correct? And if you remember one more thing, ux and uy ये क्या होता है? Gradient होता है. Correct? So I can write the if I write it in your SYBSC terms, so ऐसा कुछ आएगा. F of e plus h minus f of e, that is equal to gradient of f multiplied by that point, whatever the point is, plus an h ka term, plus it will be you can say epsilon 1 and epsilon 2 multiplied by again delta u, delta x delta y. The coordinates are delta x delta y. This is what I am writing. Do you know the total derivative का ये definition यही था? This is equal to something like th of e, and th of e can be written as in terms of delta f. Correct? The condition is that limit को हटा के I am just writing this part. I hope you are able to relate with that. Yes, I can relate that this function in terms of gradient vector, in terms of gradient. That means I can find my total derivative by using gradient, if you remember. Now you can just go back and check the notes. You'll find the much one condition would be there that they must have written it in the dot product, and here we are just multiplying and writing. You may get here that ux uy multiplied by delta x delta y. If you want to write it, you can write it like this: ux uy multiply by delta x delta y. Correct? And plus, what is that? Epsilon 1 epsilon 2 multiply dot product delta x delta y. This is what I am having. That's it. If you see this, then you are properly understanding that हाँ क्या कर रहे हैं. Correct? डेल्टा यू मतलब कौन से पॉइंट पे हम लोग डेल्टा एक्स डेल्टा वाई पॉइंट पे कर रहे हैं, एंड यू एक्स यू वाई दैट मीन्स व्हाट, दिस इज डेल यू मल्टीप्लाई बाई. Correct? So I'm just directly writing this. Similarly for delta v. Okay. Now what about epsilon 1 and epsilon 2? Let us write where epsilon 1, epsilon 2, epsilon 3 and epsilon 4 tends to 0 as delta x comma delta y tends to 0 0 tends to 0 0. Okay, so this is what I am having. अभी अपने को चाहिए क्या था? What was our main motto? And one more thing, in the whole thing ux vy, I can use my CR equation. I can use my second condition. Okay, let us go back to that later on. Now let us substitute delta and delta u and delta v का value मिल गया. Can I substitute it here in delta w? What is my delta w? Delta u plus I delta v. So can I substitute? So what will be my delta w now? it will be this plus I times this, correct? So let me quickly write with the taking real part together and imaginary part together. Okay, so this is my real part and this is my imaginary part, so I don't have any trouble here. I'll just write this first. And this is ux at x naught y naught plus, sorry, multiply by delta x plus uy at x naught y naught, this is, multiply by delta y again, delta y plus epsilon 1 delta x plus epsilon 2 delta y. This is my first part plus I times, what is next part? This one, vx at x naught y naught delta x plus vy at x naught y naught delta y plus epsilon 3 delta x plus epsilon 4 delta y, delta y. ओके, व्हाट नेक्स्ट? अभी तक हम लोगों ने एक और यूज नहीं किया है, क्या? दैट इज सीआर इक्वेशन. व्हाट इज सीआर इक्वेशन? यू एक्स इक्वल टू वी वाई and uy equal to minus vx. So let us make everybody in one variable, correct? So let us replace, मतलब सबको हम लोग x में करते हैं, ठीक है? So what will be my focus? My focus will be at uy. My focus is at uy and at vy. Can I replace it by something? Yes. uy को कैसे replace करें हम लोग? ui can be replaced as minus vx. Do you agree? And what vy? Vy can be replaced as ux. Perfect. So I'll just write it, but taking one more term, taking one more thing. That is what I wanted. Delta w क्या था मेरा? What was my delta w in the starting? F of z naught plus delta z minus f of z naught. अभी डेरिवेटिव चाहिए तो मुझे क्या चाहिए? अपॉन में डेल्टा z चाहिए ना? So I'll directly consider that. Okay. Let us write consideration part. A. What is this? No, actually I'm done with this page. I need to go back to, yeah. So let me start with this. Consider, no, consider delta w by delta z, correct? And what was my delta w? It was ux delta x uy. At the place of ui, I need to put ui. So I'll just write, you just check whether it is correct or not. Okay? Then later on we will see. First क्या आएगा? ux x naught y naught plus I vx at x naught y naught plus epsilon 1 plus I epsilon 3 delta x by delta z plus epsilon 2 plus I delta epsilon 4 multiply by delta y. I will write here. One plus I epsilon 3 delta x upon delta z plus epsilon 3 plus I epsilon 4 delta y upon delta z. Try to see whether you are getting the same thing. ux and ivx divided by delta z भी आना चाहिए, you must ask, but try to see. मैंने मतलब I am directly putting, I'll just show you. If forget about this was something, this is not part of our proof. Yeah, So what you are putting at the place of ui, you are putting minus vx, करेक्ट. तो यहाँ पे माइनस वी एक्स आया. अभी मैं क्या कर रहा हूँ, यू एक्स वाला टर्म एक साथ ले रहा हूँ. सो हियर इट इज यू एक्स एंड यहाँ पे वी वाई क्या है, यू एक्स. इफ यू टेक यू एक्स आउटसाइड देन यू आर हैविंग डेल्टा एक्स प्लस आई डेल्टा वाई दैट इज सेम एज डेल्टा जेड. सो इसलिए वहाँ पे मैंने सिर्फ यू एक्स लिखा है, करेक्ट. सेम हैपेंस विथ यू आई एंड इसको साथ में लेना है. दिस इज वी एक्स. यू आई की जगह पे क्या रखने का अपने को, माइनस वी एक्स. So if you put it minus vx here, so this is vx, this is I, correct. If you take I outside, so यहाँ पे I outside लिया तो ये क्या आएगा, vx आएगा. यहाँ पे क्या आएगा, it will be I square से replace करना पड़ेगा because there is no I term, correct. There is just minus one at the place of ui. I'll be putting minus vx ना, माइनस वी एक्स पुट किया. बट इफ आई वॉन्ट टू टेक आई आउटसाइड तो ये माइनस को आई नीड टू रिप्लेस बाय सम आई स्क्वायर. I'll replace by I square. Now if I take I common from both of them and I and Vx I am taking common, then what I will remain with, I'll remain with delta x plus I delta y, and that is same as delta z. So it's got cancelled. I'll just show you. Ux, and that is I v of that's why here there is no delta z term, and in the remaining at the delta x upon delta z, delta y upon delta z. So this is what I am having. What is the next thing? If you do you observe, we are done actually. Do you observe something? If you take limit, then this part will be equal to this plus this, and that was my derivative. That was the thing which you are supposed to prove, if you remember. Do you remember? Oh, now we just have to write it properly. That's it. बोलो अभी क्या करो. Yes. Now see, हम लोग प्रूफ कैसे करते थे डिफरेंशियबिलिटी. We used to write like this: consider, or I'll just remove that consideration part from here. I'll write here, consider mod of delta w by delta z minus what is the derivative, that is we used to write, correct, u of x at x naught y naught. See, epsilon delta हम लोग प्रूव ऐसे ही करते हैं ना, and we need to prove जो whole part है that should be less than some epsilon, correct. So how will you do? So this is my consideration part. I want to prove this part. If you want to prove this is equal to this, then you should start with consider this, correct. Now let us put. If you put, then these two people will get subtracted, they will get cancelled, and you will be having this, that is epsilon 1 plus I epsilon 3 delta x upon delta z plus epsilon 3 plus I epsilon 4 delta y upon delta z. Now the main condition is to prove this part is less than a single epsilon. That means you want to make it a real number. So how will you do that? By using triangle inequality. If you make the triangle inequality, this is less than equal to did I there was a bracket here. Yeah, sorry, this is a bracket here. So if you use triangle inequality, then this will be epsilon 1 plus I epsilon 3 mod multiply by delta x by delta z plus mod epsilon 3 plus I epsilon 4 mod delta y by delta z. Perfect. Now you want to prove this is less than something, less than a new epsilon, correct. You already know this guy is less than mod epsilon 3, but you need to think about this guy, delta x upon delta z. Can you say something about delta x upon delta z? What is delta z? It is delta x plus I delta y. So can I say that, I'll write here delta x, can I say that mod delta x is less than mod delta z? Can I say this? And similarly mod delta y, that is less than mod delta, less than equal to actually If they are 0, then they are equal. Mod delta y, that is less than mod delta z, even when they are real. Do you agree? This is because delta z क्या है? That is delta x plus r delta y. So I am just taking real part. So real part का अगर mod लिया तो that is less than your whole mod, and here I am taking just imaginary part. So these two people will be working as one in the next step, correct? Because delta x by delta z. So this is one, this is one. And what about this mod of epsilon 1 and epsilon 3? That is square root of epsilon 1. और you just directly if you want to use triangle inequality तभी भी चलेगा, और final भी लिया तभी भी चलेगा. So what will be your final epsilon? It will be addition of all them. Epsilon 1 and epsilon 2, epsilon 3, epsilon 4. चलिए यहाँ पे epsilon 2 है ना? Sorry, this is epsilon 2. This is 1 and 3, this is 2 and 4. So finally, what will be my conclusion? Limit of this is equal to this. Once you prove this whole thing is less than epsilon, then what is my conclusion? That correct? Or you can also say that these two terms goes to 0. So what should you conclude? I'll write ux plus ivx, correct? Means proved, correct? You need to write something here, correct? This whole term they tends to 0. That is also as I already told you. See, oh sorry, it is not here. So I told you each of epsilon 1, epsilon 3, epsilon 2, epsilon 4, everybody goes to 0, correct? So this whole term goes to 0, tends to 0. So that's why this limit goes to 0 at z tending to z naught. Correct. So this is the proof. Let us quickly revise the lack of time. So let us quickly see the proof once again. Okay. We started with what we are given. You are given two properties. First is partial derivative exist and they are continuous and CR equation satisfy. We want to prove that derivative equal to ux plus ivx. This is what we want to prove. So how did we start? We start with जो भी पहले एक डेल्टा W कंसिडर किया, this and delta W को delta U and delta U को just solve किया, and we observe that इसमें मैं I can use my sem 3 का definition for UX and VY. So that is what I did here. Delta U को मैंने क्या लिखा? UX delta X, UI delta Y, epsilon 1 delta X, epsilon 2 delta, same here delta 3, and each of epsilon and everybody tends to 0 when delta X delta Y tends to 0, correct? So then we started with delta W and delta W में put किया, substitute किया, and later on we use the CR equation. See, कुछ भी हम लोगों ने नया नहीं किया, अलग नहीं किया, we are just using it. Once you put CR equation, then you will be having something like this, and observe that this is equal to ux plus ivx plus something. And if you यहाँ से even ये भी नहीं करने की ज़रूरत थी. If you directly take limit delta z tending to 0, this part, everybody will go to 0, you'll be having this. That is also okay. Or if you want to go like this, then that is also okay, no issue. So what is your conclusion? That derivative equal to ux plus ivx. ठीक है? Is it clear now? Yeah, okay then. Okay, just go back once again and revise the whole proof.